Alright, so in this video we're going to be calibrating a analog transmitter here, an analog temperature transmitter. This is a Rosemount 44 RL, if you see right there the model number in right in the center of the screen, 44 RL, and the rest of the model numbers there, temperature transmitter. And what we're going to be calibrating it for is for it to be used with a 100 ohm RTD, which stands for resistive temperature detector. So we're not going to do too much background on this today. We're just going to be doing the actual calibration. So what I have hooked up here on the little trainer board here, you can see we've got this here is our electrical connections from the transmitter that are located right here, and they're broken out down here. And this is where our milliamp signal, our 4 to 20 milliamp signal, it's a standardized signal that the transmitter uses, is going to be generated. We have to supply 24 volts power, and that's what's occurring here. So on the output side of this transmitter here, across these terminals here, these terminals are connected in series with our fluke meter right down here and with our power supply. So just following from the red here being the positive of our power supply, we follow this lead out, it goes over to the red or the positive on our transmitter, and then out of our transmitter, the black lead here connects, and it goes into this coil of wire right here, which then connects to the red or the positive on our measure side of our calibrator here, our Fluke 725 multifunction process calibrator. Then out of there, it comes back and returns to the negative of our power supply right here. So that's the first set of connections we'll need to make to measure that 4 to 20 milliamp signal, that current signal. And then over here, the calibrator also will output, I'm just going to hold these wires up, will also output simulate a resistance for the transmitter so we can calibrate it and get it pretty well close, or as close as possible to what our RTD here would output for resistance when the temperature changes. So just to show you how this is connected, we have, you can see there's two red binding posts here and two red leads need to connect down, and let's just maybe pull this out here. We've got the thermocouple installed. You can see, so right down here, these two leads go to the common, or I guess sometimes called the negative or the common on our calibrator. And if I just hold these up, you can see they're going to the red right here. And the white, on the other hand, goes down to the top side. So we're using what they call a 4-wire RTD, and that's why we have 4 wires connected to our calibrator. Later on in some of the instrumentation courses, we'll talk a little bit more about why that's set up that way. But for now, 4 wires, two on the white, down to the V and the omega and the hertz and the RTD symbol. We're mostly concerned with RTD right here. And then the common here, the other two go up into our red binding post right here. So that's how we want to connect all the wiring for our transmitter. Now we're going to go ahead and show you how to calibrate. So with everything connected, I'm going to power on the Fluke 725 multi-process calibrator, and the screen is split on this meter. You can see there's a top half and a bottom half. The bottom half we can toggle to source, so we push this measure source button here, and you can see we want to make sure that it's set up for a PT 100. So we're going to push this RTD button until that reads PT, stands for platinum 100 ohm RTD right there. And right now it's sourcing 0 degrees C. What we're going to want to do is we're going to calibrate our transmitter for a range of 0 to 100 degrees C. So it's set right at 0. And what we can also do is increase this all the way up to 100. So drop this back. So there, now it's reading 100 on the bottom. And the nice thing about this meter is if you hold down 100% right here, it'll store that value. And you can do the same thing for 0. I think this has already been stored, so if I push 0, you can see it hops right down to 0 degrees. If I press 100%, it goes right back. So it's easy, makes it easy to toggle back and forth. So what it's doing right now is it's out of these leads right here, it's sourcing the correct resistance that RTD that we saw right over here, this RTD would produce at 0 and 100 degrees C. I've already calibrated the transmitter, so I like to kind of save some time. You can see on the top half here, it's reading the milliamps, right, from these terminals right down here. If milliamps does not show up when we first power up the meter, you push this white button here. You can just see it'll toggle between milliamps and volts. So there, it's back to milliamps. To adjust this, if it's not reading 20 milliamps right now and we source the 100 degrees C, inside the transmitter there's two adjustments. There is a 0 adjustment right here and a span adjustment right here that we use our screwdriver to adjust. So the span we would adjust right now since we're at 100 degrees. So I might just tweak this just so it reads close to 100 degrees. Pretty sensitive. There, so it's reading, or sorry, it reads 20 milliamps, not 20 degrees. And then we'll drop this back down to 0 and see what it's reading. So it needs to be adjusted a little bit to get it up to 4. So we might need to toggle this back and forth. So right now I'm just adjusting our 0 pot down here on the meter. So I'll just increase that to 4. So we can get it pretty close. But yeah, we'll have to bounce back and forth a few times to get it calibrated. Alright, so there I'm at 3.999, pretty close to 4. And if I go to 100% here, it should produce pretty close. It's pretty close to 20 milliamps. Might be able to get a little bit closer, but we're going to call that good for now. So what we're going to be doing when we fill out our calibration report, there's a couple things that we need to fill out. We're going to fill out our expected here, our expected milliamp reading. So this one here is going to be 4, is what we're expecting, and this one here is going to be 20 milliamps right here. This formula down here that I've put right here is used to calculate those expected values. So we call this the input-output formula. It's to convert between the two ranges. So URV represents upper range value and LRV represents lower range value. So we would plug in our values for the output scale. This would be the milliamp scale, all here and here for out, and then all of our input values for the degree C here, here, and here. So this would be 0, 0, and 100. This would be 20, 4 milliamps, and 4 milliamps, and that's what I've shown down here. So if we input the temperature that we're going to be sourcing, the 25 degrees C for the next one, if we input that into this calculation, it'll give us our expected milliamp value that we expect to see here. So that's something that we're going to do in the lab. And then we're going to verify our transmitters, do an as found check up and down, and then do an as left check after we do the calibration. So I've already calibrated the transmitter. The next step that I want to do is hook up the RTD, and we are going to be checking. We're going to be checking it to a this is what they call a dry block calibrator. We're going to be inserting the RTD in here, verifying that it reads 20 milliamps at 100 degrees C, and then we have an ice bath here, and as long as we agitate the ice bath, it's going to give us a very, very close reading to 0 degrees C. So we're using crushed ice and water here to build our ice bath. As long as it's agitated, we'll get a very, very close reading to 0 degrees, and we should see 4 milliamps. Alright, so I have our RTD connected. You can see these binding, they call the binding post. They thread up and they'll clamp down onto the wires of our RTD. So I've got them all connected. They're color coded, and so it just lines up white to white, red to red. And over here we're going to be looking at our milliamp value on our fluke meter here. I've disconnected the calibrated the leads for calibrating the transmitter here. And what we're going to do is we're going to take this RTD and we're going to dip it in our ice bath here. And I'm just going to agitate the ice bath and stir it around. And what we should see is this value on our fluke meter get quite close to 4 milliamps. The temperature is a little bit of a slower process, so it'll take a little bit longer to get down to that, but you can see it's still dropping. So maybe check back in here after it's falling down. So you can see that it's dropped down. We're pretty close to that 4 milliamps. And just to kind of check, I've hooked up a thermocouple down here to the meter as well, and we just need to push this TC button until it reads K, because the thermocouples are color coded. Once another thing you'll probably learn further on the instrumentation course, but you can see it's pretty close to 0 degrees C there that it's reading in the meter. So that means that ice bath is producing 0 degrees C. And we're pretty close. It might be off slightly. All right, just maybe hold my RTD up a little bit higher, more to the center of the ice bath. And you can see it's kind of falling right back down to 4. And as long as I'm agitating the solution, I'm going to call that probably pretty good, because we're off. And maybe this ice bath at the most might be 0.1 of a degree C, so it's pretty close. All right, so our last check here with the verification now with the RTD all connected. And I just kind of wanted to stress that it is good to do at least 2-point check after you've connected the RTD, even if you use this process calibrator to calibrate, just to make sure that the wires are all properly connected and stuff like that, and things seem like they're reading correctly. So I've got the dry block calibrator here. It's set for 100 degrees C. Manual recommends to have this warmed up for about 10 minutes before using it, so the temperature stabilizes. And so setting that temperature here, there's this set button, and if you push it a couple times here, and there, so we toggle it till we get to it. Once it's reading a number right here, and if you hold the set button down, it should let you change that number there, you can see, but we want to set that and leave it at 100 degrees C. And then once that it reads there, let's just see, yeah, so set, and there. Now toggle it, it's kind of funny unit here, there, yeah, once the reading shows the unit right here, that means that it is giving you the reading of what the temperature is inside the dry block right now. So right now it's at 99.9, and I've just thrown the RTD in here. It was at 0 degrees C in the ice bath, so that's probably why we saw our temperature drop right here. There it's back up to 100, and if we just look, temperature is a slow process, so we'll just look over here at the meter here, and yet we're getting right up close to 20 milliamps. So it probably won't be long before it stabilizes here, and it should be reading 20 milliamps. Alright, so the last part of the lab procedure here, after this is all filled in, and after we've done our 2-point check with the dry block and the ice bath with the RTD installed, our last step is going to be, we're going to give you a solution of water here at an unknown temperature. You're going to measure it and read the milliamp value that's displayed right here. We're going to read that value, and then we're going to use this input-output calculation in reverse to figure out what the temperature is. So it's going to be the last step of the lab. Just so you're aware, you want to come prepared, maybe familiarized with this equation right here, because that's basically what a transmitter is doing. It's going from one range to another. It's taking a input range and outputting an output value, a milliamp value here, and right. So now what we want to do is we're going to take this in the last step here. We're going to take a milliamp value that's displayed on our Fluke multimeter and determine what the temperature must be of that solution that's given, the unknown solution.